Hey guys, Miss Smith here. We are going to go over the study guide for our next quiz, which is Module 2, Topic A, Eureka Math, Tennessee Edition for 3rd grade. This topic quiz covers how we have units of measure that involve weighing things in grams and kilograms, and units of measure that involve finding out the liquid volume of things with liters and milliliters. So let's jump in. With grams and kilograms, if you're like most Americans and not super familiar with the metric system, a gram is about the weight of one tiny little cube. And the students have done a lot of work with this. They've weighed a lot of things in the classroom, so they're getting a feel for what different things might weigh. But to put it into perspective, a gram is a very light weight. To make a kilogram, you need 1,000 grams. So a lot of grams go into making up a kilogram, 1,000 to be exact. And we talk at school about how a pineapple is a good reference point. A pineapple is generally around 1 kilogram. So that would be a really good way to think about that. The good news is we can reference back to this cube as we answer each of these questions. Number 1 says a cat weighs about 5. So I'm going to think to myself, does it weigh about 5 of those cubes? Or would it weigh more than that? I know a cat is going to weigh way more than 5 of these cubes. It would weigh about 5 kilograms. I'm going to circle that, and then I'm going to come over here and put the abbreviation for kilograms, kg. The next one, a carrot weighs about 15. I know a carrot is a pretty light vegetable. It's not going to be near as heavy, much less heavier than a cat, so it would be grams, G. A rabbit weighs about 3. Again, a rabbit is going to weigh much more than 3 of these cubes, so a rabbit would weigh about 3 kilograms. And finally, a frog weighs about 300. Now, thinking about 300,000 cubes is a lot of weight. A frog is not going to be that heavy. He's going to be about 300 grams. Number 2, we have a story problem involving weight. We ask students when they're doing a story problem, first they need to read it, and as they're reading, we want them to underline anything that might be important and notice numbers. Okay, so we start reading. The total weight of 3 wooden blocks is 30 grams. We've got a period. We're going to stop there and go back and notice and underline. Total is a big important word in math. The total weight of 3 wooden blocks is, so the total is 30 grams. Each block is the same weight. We talk about in multiplication and division, you have to have equal size groups. So I know in my head this is going to be a multiplication or division problem because I'm dealing with equal size blocks, each block being its own group. The question they want me to answer is, what is the weight of 1 wooden block? Okay, there are lots of options students have for drawing something. So first we read, then we need to draw a representation or a strategy for solving it. Students could literally show some skip counting by 3s to get to 30 and figure it out from there. Students could draw the actual picture, 3 blocks. Students could draw an array. Students could draw a tape diagram. For this one, we're going to draw actual blocks. So going back to my story problem, I had 3 wooden blocks. And I know that all 3 of them together, the total is 30 grams. The other big thing we discuss in math with division is that you can't just start giving grams to one group, because then the other groups may not end up the same weight. Instead, we have to give each group or each block the same amount of weight to ensure that it stays fair and equal. I'm going to give you 1 gram, you 1 gram, and you 1 gram. A good organizational strategy is then we write down how many grams we've given out so far. We've got to get to a total of 30 grams. So I'm going to keep giving out grams. You get another one, you get another one, and you get another one. 6 grams. 9 grams. 12 grams. 15 grams. 18 grams. 21 grams. 24 grams. 27 grams. And I'm going to add another block in here, 28, 29, 30. I made it giving out all 30 grams. I made it to that total. I made sure that every single group or every single block was the exact same amount of weight. I'm going to go back to my question. What is the weight of 1 wooden block? I can look at any of these, but I'm going to look at this one right here and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The answer would be the weight of 1 wooden block is 10 grams. Now, many of your children are actually ready for writing equations, okay? So we want to write, obviously, our answer, which we did right here. But a lot of your students are already capable of writing that equation that would go with it. I know that division always starts with the total. This is a division problem. I have a total amount of weight and I'm dividing it between 3 blocks. So I could say 30 grams divided between 3 blocks is the same as or equal to having 10 grams in each block. Some students really like to also go ahead and write that multiplication. In this case, it would be a missing factor multiplication, as 10 grams was our answer or quotient. So here I would say I have 3 blocks that each weigh 10 grams, and that is the same as 30 grams total. Just as long as the student is boxing up the correct information, that being the information they were not given, the information they had to find. All right, let's keep rolling. Question number 3. Zara painted some rooms in her house. The picture shows the amount of paint Zara had when she started painting. Okay, I've read, and I'm going to think about, I don't notice any numbers, but I do notice this is a starting amount. I'm going to look at this illustration that they've given me. The starting amount was 20 liters. Liters is a unit of measure that represents 1,000 milliliters. So liters is a larger quantity for liquids. We talked about how often we'll go to the store and buy a 2-liter, okay? And then we've looked at some things in class that are also 1 liter. She started with 20 liters of paint. When Zara finished, she had 12 liters of paint left. Okay, so that was when she finished. When she finished, there was only 12 liters left. How many liters of paint did Zara use? So we need to find the difference here between these two amounts. She has used up approximately this much paint. I can't be approximate though. I have to find an actual answer. Here we know we started with 20 liters and I have ended up with 12 liters. So I can think about that as a subtraction problem by either taking away those 12 liters, or I could also think about it as we used this much and I was left with 12 liters. Either way, we are finding the difference between those two amounts. We can solve subtraction a lot of different ways, but because I have a 0 here, sometimes students have a hard time with what you may have grown up with the term borrowing. We call it maybe regrouping here. So we could do a place value chart, and then we would need to go to our tens and get a whole nother group of tens. But we could also do a strategy which is called the arrow way. I finished with 12 liters. I started with 20 liters. And I want to know how much was used in between there. Subtraction can also be thought of as a missing part to an addition problem. So in essence, I have 12 liters at the end. How much would I have to add back to get to my original 20 liters? To me, going forward and adding is much easier for students, especially when borrowing is involved. I know that 2 plus 8 would give me a nice even 20. And that was my ending point. So my arrow needed to be a lot longer, or my line needed to be shorter. We started there, we finished here. Students could accomplish the same thing by going backwards. And a lot of times they use a number line to do that. 20, and they hop back maybe one at a time. 19, 18, 17, 16, 15, 14, 13, 12. Hope you can see that. Yeah. So when we hop backwards, this is 1, 2, 3, 4, 5, 6, 7, 8. We still got the same amount of paint that Zara used. So the correct answer was A. I'm going to show one more strategy because everybody kind of has their own thing that they like to do. I'm going to scoot that up just a titch. And this would be a place value chart in order to subtract. I have tens and I have ones. And I know that in this story problem, I was starting with 20 of something. 10, 20. If I'm over here on a place value chart, each disc or circle represents counting by that amount. So this would represent 20. From that 20, I am going to need to take away the 12 to figure out the paint that was used. When we look over here, I don't have any ones, and I need to take away 2 ones. we're going to come next door to our richer neighbor, the 10s, and we're going to let our 1s borrow those 10s, or that 10. When he comes over here, though, he doesn't count by 10 anymore. This is a different neighborhood. He counts 1 at a time. So I have to count 1 at a time to represent 10 or get to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I do have enough to take away the 2, and I have enough to take away the 10 that is in my 12. I took away 10, 11, 12 from the 20. I look to see what is left. 1, 2, 3, 4, 5, 6, 7, 8. Regardless of the strategy they use, students need to be able to understand this type of story problem is asking them to find a difference. Moving on to number 4. All right, number 4. 1 bag of sand is shown on a scale. So I'm looking here at this bag of sand. What is the weight of the bag of sand? Now, this is something that can be challenging for students. Reading a scale, they have talked about in class how a scale that is analog like this is very similar to a clock. I have a hand that starts at 0 and it moves its way around. There are things I need to notice. I need to notice that this scale only goes to 30. That tells me that I am not counting by a large amount. I also notice that halfway around the scale is 15. I notice that there are some darker tick marks, and I'm starting to wonder if perhaps it's 0, 5, 10, 15. So those darker tick marks are showing me that we are counting by 5s, just like a clock, but then we have tick marks for each minute, or in this case, each kilogram that are in between. Here was 5. If I count on to where the hand is pointing, I would have 6, 7, 8, 9, or some students might look at it and say 1 less than 10 is 9, but this bag of sand weighed 9 kilograms. So the first thing students need to be able to do is read a scale. Next, we have to use this information to help us solve a story problem. Gabe buys 4 bags of sand. Okay, I just found out how much 1 bag weighs. What is the total weight of 4 bags of sand? I'm going to draw a picture here. This time we will use a tape diagram. Got 4 bags of sand, each box representing that bag of sand, and there is 9, 9, 9, and 9. Now, one of the things we talk about in class is that if each of these weighs 9 kilograms, 9s can be hard for us at this point to count by. So there are a couple of different strategies. Instead of trying to skip count 9s, students could draw something to represent each of those 9, like a circle or a square. So 9 in here, 9 in here, 9 in here, 9 in here, and count all. Okay. Or another strategy students have is that they could break it into some friendlier numbers. So for example, I know 9 is made up of 5 and 4. So I have essentially drawn 9 circles, but I've organized them by breaking it apart into 5 and 4. 5 and 4, this one weighs 9 kilograms. This one weighs 9 kilograms, pardon me. This one weighs 9 kilograms. Okay, so each of these now represents a bag of sand that weighs 9 kilograms. I can skip count the top part by 5s. 5, 10, 15, 20. Okay, so I have 20 kilograms, but I have some more. 4, 8, 12, 16. I have 16 kilograms. And if I put these back together, I have 20 and 10 is 30. 0 and 6 is 6. So I have 36 kilograms is the total weight of 4 bags of sand. Okay? This is a multiplication equation. Basically, we had 4 bags of sand that each weighed 9 kilograms, and I found out the total weight was 36 kilograms. Number 5, there are 192 liters of water in Jayla's rain barrel. Jayla uses, that's going to be an important word, 76 liters of the water for her garden. How many liters of water are left in Jayla's rain barrel? I know if I use something up, I have less than when I started. Thus, I have a subtraction problem. I had 196 and I used up, oops, I have to go back and double check. I had 192. That's why it's good to circle them. And I used up 76. Now, most of us grew up with a traditional or standard algorithm where we lined things up. Students really haven't been exposed to this yet in 3rd grade, although they will. But I wanted to place this here so that you could see a side-by-side comparison of how traditional or standard algorithm is similar to what they do know how to use, which is a place value chart. We have our hundreds, we have our tens, and we have our ones. I'm going to put my entire amount, which was 100, 10, 20, 30, 40, 50, 60, 70, 80, 90, to 192. I've represented the entire amount, and now I'm going to take away this from the original amount. When I look in my ones place, I do not have enough to take away a 6. In essence, we're going to have to go next door to our richer neighbor and ask them, can we borrow a 10? They're really nice neighbors. They're going to let us. When I come back to my neighborhood, though, we have to count that 10 one at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What we did growing up was we said, I went here and I no longer have 9. I have 8 now in my tens place. And then when you look what we have now, we don't have 2 anymore. We have 12. So this is kind of how you might have represented it, but here is the reason why. Now students do have enough to take away the 6. So we're going to mark those out. 1, 2, 3, 4, 5, 6. I look at what is remaining. 1, 2, 3, 4, 5, 6. And I'm going to record that. Next, I look in my tens place. I have 8 tens, and I need to take 7 of those away. I'm going to take away 1, 2, 3, 4, 5, 6, 7, which of course leaves me with 1. 8 minus 7 is 1, 10. Finally, my hundreds, nothing is happening. So that 100 remains. It is still there. I had 116 liters of water left in Jayla's rain barrel. This was a subtraction equation. Thanks for watching, and I hope that was helpful. Happy studying!